Hello, everyone. We are the Fungineers. I'm your host, Zachary Bowen, and this is.
I'm the co-host, Mackenzie Cook.
We're here to talk to you about our FEDD project today. It is a educational video game. This broadcast will cover what was the process we went through to design our product, explain the research component of our project, and to wrap things up, we're going to all explain to you what we've learned from this experience.
Now, let's go to Walker to learn about the design process.
The engineering design process that we implemented in this product. So first step was identify the goal, and this goal was sort of provided for us, and it was to create an educational video game to cater to kids, primarily in elementary or middle school. And the next step of the engineering design process is to create a team, and our team was given to us, but within that team we divided the labor. We had one person writing our research paper, doing research, one person primarily making the game, one person making posters, and the other two were helping everybody out. The next step of the engineering design process is identifying criteria. And this criteria was provided for us, and it had to be a STEM-themed game, so it had to use science, technology, math, something of that nature. And it also had to be a minimum of 5 minutes of length. And like I mentioned earlier, it has to be child appropriate. It has to cater to children's educational needs and their curriculum, which was part of the research we did. And another restriction was we were restricted to 3 video game development softwares, and we ended up choosing Game Maker for ours as I was more familiar with it. The fourth step of our design process was the search for solutions. Now originally we were thinking of a geometry-based or algebra-based game, but those seemed a little too abstract for younger players. So we decided to go with projectile motion, which introduces physics, which is not usually taught at that age. And it also has many themes that can go along with it, so it gave us a lot of creative freedom in making the game. The next step in our engineering design process was feasibility. Now in this project we had a lot of constraints. We had time constraints. We only had about a month and a half to finish it. And we also had limitations on the software packages we could use. They were restricted in their scope and their scale. And not many of us had any experience building a game, so there was a lot of a learning curve too, and that hindered our potential. Now some of our preliminary designs after we chose projectile motion were very bare bones. The original design was just a green box flying through an empty space. And once that took a long time to get working because there are many problems like falling through the floor or flying upside down or falling up, things like that. But we eventually got that down, so we had projectiles actually moving, which is the basis of projectile motion. Okay, so for our intermediate design, we decided to go with a football theme. This allowed us a lot more room for creativity, and it made it a lot more exciting and appealing to many more demographics. Whenever we did this, we added a football sprite for the projectile, and we added a receiver to the far end of the room as a goal for the projectile to reach. And these images provided a problem because their odd shapes and sizes had made us scale things very differently, and it caused some problems. Our final design, we completely took off with the football concept, and we added a score to add an element of pressure, competitiveness, and excitement to the game. Then we added defenders from the opposing team to provide obstacles for the projectile to avoid, and as an enemy to spend more time in the game and give you a sense of accomplishment by overcoming them. And finally, we added a menu and some context, like a fourth quarter comeback, and we added the score and how high stakes it was, and that just made it a lot more exciting. And so that's been our design process. And back to you, Zach. So here we have our main menu, and we're going to go ahead and get into the game. So here's the context for the game. You're down by 29 points against the Tar Heels in the fourth quarter of the game. And on this day, it's very windy, so you have to adjust for that and adjust for defenders in your throws. So here we're in the main game, and we're adjusting our launch speed and our launch heading. And you can see the wind heading is at negative 12 degrees roughly, and it's blowing at 18 miles an hour to the left. So that's roughly where the wind is blowing, and you have to adjust for that and adjust for the defenders in your throw. So we're going to throw it, and you see we got an interception, and now we overshoot. And you'll notice you're not getting penalized for missing the defender, and that's meant to help trial and error solution methods. So we're going to try and score a touchdown, and there we go. So you see the score has gone up by 7, and the wind direction and wind speed are randomizing. And when we reset for the next drive, we will have new wind direction and new wind speed. That's pretty much the game.
Thanks for that, Walker. Now we're going to move on to our research specialist, who will explain to you the research component of our project.
I'm Will, our research analyst. Our target audience was youth ages 13 to 18. We chose them because through this group, the North Carolina educational system teaches them the same concepts we implemented in our game, such as algebra and physics. In addition, through our game and projectile motion in general, it teaches them trial and error, force, and launch relationships.
Thanks, Will.
All right, now we're all going to go over what we've learned from this project.
We learned about all the components that go into creating an educational computer game. We also learned how to effectively work as a team in order to create the best end product. Most importantly, we learned the importance of engineering and building fundamental engineering skills in young adults.
Well, that just about wraps things up. In recap, our game teaches children 13 plus the basic principles of projectile motion through trial and error tactics and familiarizes them with the force and launch angle relationships of projectile motion. Projectile motion is an important STEM concept and is related to the physics and trial and error solutions in the NC educational standards. As a group, we all learn how to better work together in a group environment, and we learn the basics of designing a simple computer game. And that's all for today. And as always, go to hell, Carolina.
Go Pat!